Well, hi, good morning, and thank you so much for joining me in my shop. Today is June 20th, and it's a gray, rainy day outside, kind of cold, but the hot spell is coming. In a couple of days, it's going to get very hot here. So the radio's back out on my bench after being in the cabinet for a test. I'm just being a little bit distracted here by guess who? This thing. Where'd it go? He's trying to chew the wire in the back of my camera here. There's a number of minor problems, or maybe not minor, but a number of problems with this radio that still need to be ironed out. One of them is the wonky tube here, which I think just requires a replacement of this tube. And another one is, the one that's kind of troubling me, is the tone control is having no effect on the radio. And I also think the radio is producing less volume than it should, and I'm guessing those two problems are related. First thing is, I think I'm just going to replace this guy here, rather than fiddle around with him some more. I think this is the tube that I tried to repair the grid cap on it. By resoldering it, it seemed to work, but then in the end, no, it did not. And this is a, what is this? 6K7, so I'll get another 6K7 here, and we'll put it in. And as you can see, I've got quite a few 6K7s, and this is also 6 SK7s in here. And see, a lot of them have numbers on them, and that's because I've tested all these ahead of time, and I've got a record. I know how number 6 tested, if I wanted to look. But subsequent to doing all this, I've acquired more of these tubes, and I just toss them in here, but I don't put a label on them. So see, 6K7, here's another one that came out of there. Two 6K7s not labeled. If I use a labeled one, I have to correct my counting list here, my list of tubes, so I'll be lazy. And I'm pretty sure one of these is going to work. Let's find out. Now, are you going to stay on top of this? How did this get moved over like this? Holy smokes. Holy smokes. What's going on here? What have you guys been up to? Somebody's been up to something. Okay, you're going to have to jump off here. You're going to have to get off, because I can't test a tube with you on top like this. Are you listening to me? Okay, you're leaving. You're leaving now. Okay, I gave him the boot. 6K. 6K7, 6.3, signal level 2, bias is 33L. The numbers are 17342, 17342, and 0610 610 43 D. Grid cap. 6.3 to 23L. This is not right. 33L, that's correct. 17342, 17342, 0610 0610 43 D. Okay, we're good. Now it might be a little hard for you to see the actual reading. I think I can shade it a bit. That's not going to help much, is it? I'm trying to shade it. Can't shade it. Okay. Good. Shorts. no shorts. This test should come up to 1/1000. Should be up above my finger there. Now you can see it's well above. There's nothing. Is there something wonky about this? No, I think it's just a contact there. Good. Okay. That's the first job done. Put this one in. Okay. Next job is to, oh, by the way, this dropped out of the radio. This knurled up piece of what? So this is what's left of what they had shoved over the string here to increase the clamping inside the radio to clamp the string. So it's basically paper. I'm sure it's just paper and shoved in there. I could do the same perhaps. We'll see. So tone control, not providing any tone control at all. I'm going to have to tip the radio up and to make it more accessible, to make it accessible. And that's going to take a minute. Good, I'll get that done. Okay, so I did take a peek at this when the tone control stopped working, and I couldn't see anything that was obviously weird, but let's look at it again. So this is the tone control. This on the back of the tone control is the on-off switch here, but this is the actual tone control. You see one terminal is not even connected, just these two. So this is nothing more than inside here a variable resistor. Coming off this leg is the capacitor, which comes down to a terminal here. One possibility is I put it on the wrong terminal. I don't think there's much likelihood of that, but the other possibility is I put the wrong size capacitor in. Another one is there's cold solder joints in here, and that they look good, but they're not. I resoldered down here where this black wire connects to the chassis. Maybe that was bad. Looks fine. Everything looks absolutely fine. That's the problem. So really the most likely thing here is a wrong size capacitor or wrong connection down below. Now, is there not a diagram that shows the parts layout? I think there is, so I'm going to take a look at that to start with. Okay, so here's a diagram of the part layout, and here's the tone control, and here's the capacitor I'm talking about, and they don't quite show where it's connected. Now I have it connected here. 190 volts, so that's the plate voltage, and there's a P right in there for the plate terminal of this tube, and it's tied to the next terminal over. And so I'm just going to look in the radio now just and see that that's exactly what's going on in here. Okay, there's a resistor off of that and another capacitor, so we see a resistor here. Here's another capacitor. This is shown going this way, this one here, C45, but I've got it coming across to here. And this is a grounded terminal, so probably this is a longer capacitor heading for a grounded terminal over here. I make a mistake with that. That would kill it right there too. Oh, maybe what's going on there? Yikes. Okay, so let's look back at the radio. I've seen something I shouldn't see. So I'm looking at this yellow capacitor and how close it's tied to a terminal over here, but it's passing this terminal and it looks like it's virtually in contact with it. That would be really bad. That would be a really bad thing. So I don't think it's the case. Oh boy. Oh boy. I'll show you that with a close-up camera here. So the yellow capacitor lead goes to the right, and it goes all the way past the black wire, past this wire here, and it ties to a terminal on the other side. But I've got the capacitor wire laying right across this terminal here. Oh, it was stuck on it. So it's saying. Well, that might have been a problem. I don't know exactly what would be going on there, because that's kind of a, I don't know what's what. I'm not going to try to figure it out. Could that have been the tone problem? Strikes me this would be a much bigger problem than just causing the tone to go down, but we did lose volume. I don't know, it's a scary mistake. I'm lucky something didn't burn up from it. Doesn't even look that well soldered on this side. It is though. Okay, so I have made a small change in the radio. I guess we better operate it at this point. Let's just take a close look up in here. It's a little sloppy on the wiring. The automatic focus is automatically annoying me. So I don't think there's a problem here, even though the wires are a little pretty sloppy. Yeah, not the nicest soldering job, but I don't see that it would cause any kind of problem. Well, I think we need to operate the radio and see if I didn't, lifting this wire over here didn't solve the problem. Okay, I think we're ready for a test here. Speakers connected, antennas connected, plug's not in. Switch is off. Okay, dim bulb's on. Here we go. And if there really was a short circuit there, and if it was a really bad thing, like if it was a short circuit on the power transformer or something like that, it would have become pretty obvious for a number of reasons, but one of them would be the dim bulb lights would have come on full tilt and would have told me right away that something's up. Plus, you apply power on a radio that has lights and the lights don't come on. If there's power going into it, that's a bad sign too. So I guess what I'm saying is that if you do make a mistake, that could seriously affect the radio. Dim bulbs or just paying attention when you first turn it on to what's happening could save the day. Okay, this radio should be warmed up. Not hearing a thing. Oh my gosh, the volume's right up full. What's going on? Oh, we don't have the voltage up full. That's right, we're only on 76. Still very low volume. Like, okay, tone. No change at all. No change at all. I don't know what to say. No change at all would be the capacitor is far too small. Too small a capacitor there. That wouldn't explain a lower voltage, but that could be some other thing going on. Okay, so what size is the capacitor that's supposed to be there? I thought I knew. Let me just turn this down a little bit. Well, we tuned something out. Feel a little better. That would be Chinese, eh? That'd be some community radio station from Toronto. Okay. Right, we're going to look at the schematic and find out. So it's C24 and C24. Oops. What is it? Part list here. C. We have to look very closely at this. See, so there's C24. I got my eye on it right away. 0.005. I'm pretty sure that's what's in there. I put in a defective capacitor. It's very unlikely. 24.005. Radio's making some scratchy sounds. Well, first of all, there should be plate voltage across that capacitor. Let's check and see if we can measure some of these things. It could be the cold solder joint, and I haven't dealt with that possibility, but it's very unlikely. Very, very unlikely. I'll use this meter, and we'll just look for B plus. It'd be like I don't know, a couple hundred volts or something like that. And we should find it on this wire. This wire. 250, 260 volts. And on the other side, should be nothing. There's nothing. Okay, this should show a 0 here. Okay, let me turn the control so maximum resistance is in place. That's where it is right now. Isn't it? No, it's not. It's yes, it is. That'd be maximum resistance. We'll check the ground here. If the ground is off, I'm going to put a big voltage accidentally across this meter. You don't want to do that. Power off. If there's something funny going on, I could potentially put a big voltage across here. Okay, we should see this kind of thing happen to the meter. And yes. So what about the control itself? Does it have okay, there we go. So 0. You can see the resistance going up. Sort of going up. Not doing very well, is it? Oh, look at that. It's all over the map. It's open. It's open or it's high. Let's go higher here. It's probably a 1 meg ohm resistor. Is probably what it is. 1 meg ohm. Not terribly reliable, is it? Is that the problem? Not very likely the problem. Let me clip this on here. Do this a little better. So these controls can get dirty inside. And usually the contact is hit and miss then. As you turn the control, you get a scratchy sound. So that's one limit, a little over a megohm. It's kind of all over the map, isn't it? How to get that low? How to get that low? So it seems very low through almost half its turn, and then all of a sudden it gets excited, and then it goes up very rapidly right at the end here. Now maybe that's normal. I think we should spray some cleaner in there. Didn't I not do that already? Pretty sure I did. Come out. I have a hard time. This fluid is so invisible when you can't even tell if you're spraying it out or not. Okay, we're at the 0. A lot better. Does seem better. I don't think there was ever a time where there was no contact in here. Very resistant should have caused the tone effect. We have to check the capacitor. So that's a little tricky with it in the circuit. So I set the variable resistor at its maximum. And wasn't this test machine giving wonky answers the other day too? It says it's a resistor. Wow. Maybe it is. It says it's a resistor, 1.1 megohm, so it just read the resistance to ground. Didn't even see the capacitor, which is in the same. It's in a kind of a parallel circuit there, so that didn't work. So we really, I don't know what else to do. We're gonna remove the capacitor. Remove one leg on the capacitor and see what's up. Can't say I've ever had a brand new capacitor be defective right off the bat, but capacitor's off. Might be safe to say the radio is behaving as if there's no tone control and no tone control capacitor. So we'll try it again with this guy. My faith in this meter has been damaged a bit, so we'll see what it says. Capacitor, it says it's almost 5,000 picofarad. That'd be 0.005, which is exactly the right value. 0.005 microfarads. That's exactly the right value. what else could be going on that would interfere with the operations of the tone control? And I think the answer is I haven't got any idea what else could be going on. What else? What other factor could affect the tone control? Let's look at the schematic again. The tone control is right here. Let's zoom in on it here. This is a very, very common method of tone controlling. So you have the tone capacitor and the variable resistor. And what you're doing is you are cutting some of the high frequency sounds and dumping them. You're dumping them into the chassis here. So to lower this resistance, the less treble makes it through the radio. So this is working. Like here's another one right here. What if this is wrong? Oh my gosh, wait a minute. I've got a fairly large capacitor hooked up there. Maybe that's my mistake right there. 100 picofarads, and I've got some. I'm looking at this capacitor. That's what's happening. I'm looking at this one. 0.01. It's probably a 0.01. So what if this? Well, I mean, this is a small capacitor compared to this. Another one down here. This is also small, but it's on the far side of these resistors. You don't need tone. Yeah, this is kind of interesting. So you're tone controlling here. Then part of the signal is sent down to here. Yeah, part of the output is sent down to this grid where the signal is inverted. So you've already tone controlled it. So the treble's out by the time it's coming down this way. So right now I have the capacitor and the tone control disconnected completely. But I'm willing to bet if we ran the radio it would sound exactly the same. Because the problem is somewhere something else. What other capacitors did I change? This one. And this one. I can see them. One of those was the one that I thought might be shorted. One of these. Well, you know what? Like, there's just nothing jumping out here saying, hey, that'll be the problem right there. How about that guy? That's a big one. I don't recall that one. I think I'm looking at it. Just because I don't remember doing it doesn't mean I didn't. C46. C46 would be, and this is all turned around now. Wait a second here. Let me get this all lined up with the radio. Transformers here. So I think we rotate 3 times. Now it's just like the radio I'm looking at. Capacitor I'm wondering out is this big one. I think this one. Yes, it'd be this one. C6. And again, they don't show the wires all the way. C6. Did I say C6 when it says 26? What did I just do? C6. C6 in the tone control area. C6. Now that number suggests the capacitor's way over here somewhere. Yeah, so there it is, C6. So this has nothing to do with what I'm fooling around with in the tone at all. What got me looking at it? Because it's a big capacitor just nearby. Well, I don't know. I don't know what the story is. I gotta stop and ponder this a little bit and come up with some way to kind of investigate this. I mean, beyond what I've done now. What exactly? Okay, so I've been discussing this with my cat. What he said is, if you add up all the different symptoms, apparently low volume, apparently no effect of the tone control, that what that suggests is there's another capacitor in the wrong position I put in, somewhere in here, in the wrong position, and that capacitor is already knocking the tone down enough that additional knockdown of the tone with the tone control is insignificant, not noticeable. So what capacitors could those be? And so of course I'm looking in the tone area down here. I can't find anything, but you know what? He's just come around now, and he has sent a message to me. Maybe it's the capacitors around the volume control. In that area, I've made a mistake and put in something too big. This capacitor here, unusual one that I put in, this is a 0.1. Or is it? Is there a chance it's a 1? Would that even matter? This one's coming off the center of the volume control. Wow, it's almost a short right there. I'll show you that one. Now some might say, well, that's sloppy work, Jim. Well, some might be right. Ooh, that is close, but it's not. I'm looking at the grounded wire here and how close it's getting to this terminal right beside it. It's just close, but so we're going to move it away though. Now that would have, if that were touching right there, that would have put a ground right on the output of the volume control, and we would have heard nothing at all. And this capacitor here is another one. This one does have a tone control effect. It's related to this tab on the back of the volume control here. If I did this one wrong, this might do it. What's the size there? Can't quite see the size, can we? I hate to rotate these things. That's one way to damage something. This could be the guy, though. This could be a problem. I wish my camera would focus better. Yeah, that's great. Thank you. That's just fantastic. Well, I don't know. I don't see a value there. I just don't know how to read those numbers. Okay, let's investigate that capacitor on the schematic and see what it's. So this is the one that ties the tab at the back right to a ground terminal here. This is a ground terminal. Okay, let's take a look. Okay, so the volume control is here, and we have a capacitor that goes through a 22K resistor and then 0.025 to ground. This is the one I'm wondering if this is not the right size. Where's this resistor here? Hey, yeah, where's the resistor? There's the resistor. Okay, there's something more going on here. Let's look back at that at the radio. Okay, we need to use the close-up camera. What have I done here? Maybe this is the mistake right here. So I have, there's the resistor. What is that? There's two taps on this control. Where was it made? Streetsville. That's near Toronto. In Streetsville. Well, so this capacitor in the center of the screen is going from the tab straight to ground. And then we have another tab with a resistor, but that's not what the schematic shows. This one in the middle here doesn't exist. You can see the resistor is original. I didn't do anything with it, and I just replaced the capacitor where it was. So is this a variation from the schematic? What are you chewing on over here? What are you doing? No, don't get interested in that. Let's go on the keyboard. Sure. We'll just sit here on the keyboard. But I did discover there's an on-off switch. I keep the keyboard switched off now, unless I'm using it. Well, we need to investigate these capacitors and find out what the story is, and how come there's a two-tab control in here, but I thought I saw only one. And what's all that mean? Let's look back at the schematic here. Okay, volume control is here. Well, there is this is the wiper that you would are turning and moving. This is the tab on the back, and there's the terminal numbers 1, 2, and 3. Why? But the control has two tabs. What's going on there? It doesn't match. If it doesn't match, then perhaps the capacitor size shown here is incorrect for that radio. Maybe there's another schematic that shows a different volume control arrangement, and this is a different size. But I took one out. I would have looked at the size to match it against the schematic, or did I? Maybe I didn't do that. I usually do that, but you know, just like everybody, I'm not 100% on stuff. So maybe I took this out. It's a different size, and I never noticed. And then I've gone and put in this one, a fair size one. So if there's two tabs, and now I've got a capacitor basically between the two tabs, that's to some degree kind of shorting out the volume control, sort of, kind of. I don't know what that would do. That would do some weird stuff. 22,000 is the resistor, a 22K resistor. I'm looking on my own here. I have the feeling you can't tell by looking at it. So body and dot. They're all red. The body is red, the end is red, and the dot, well, I really can't see the dot. So body and end are red. So there's 2-2 right there, and the capacitor, the resistor is a 2-2. So almost certainly that's this same matches the schematic. It'd be that this terminal is not. See, this is actually done totally different. This is the way it's done. Is the capacitor and resistor are switched in position, which you might think means nothing, and it would normally mean nothing. But in this case, because there's two tabs, the capacitor is going from here to this other tab. Maybe the resistor should be doing that. The resistor is doing that, Jim. The resistor is doing that. The resistor is between the two tabs. Taps. Resistors between the two taps. Oh, why don't I get an ohm meter and check out what these taps are doing? Okay, let's do that. So the taps I'm talking about, one is here, and the other one's back over here. There's the resistor in between. A little hard for you to see it. There it is. This is the capacitor. The schematic shows. Oh, wait a minute. This is showing. This is the right. If this is the tab, then it comes off resistor to the capacitor to ground. So this is showing the same way, except this tab thing here. So is this really a tab, or is it just a terminal, a handy terminal? Far-fetched it would be a handy terminal. I think I could tell what's going on by taking some resistance readings. I don't know, it's all mixed up in a circuit here. Well, no DC can get through this capacitor, so the DC test, what this is going to do is going to be restricted to where I want it to go. That scared you, scared me, scared my cat. Would you like to leave now? How about you leave now? There he goes. Yeah, he's happy to leave because the shop is scary. Get out of here. Okay, that's my cat talking there. That's his voice. Now, so we have the ohm meter connected to this tap here. This tap is connected maybe inside through this resistor inside. Let's go across this resistor first. What do we get? We should get 22. Okay, so we get 25. That's good. That's okay. Okay, so the resistor is there. Everything's behaving the way I would think. Put this on ground for fun. See what happens. Okay, so there's no ground involved. Now we want to hook up to the slider. The wiper, I guess is the proper word. You would think you would see something there. Well, a little difficult when things are not clipped together. Okay, so the question is now, the effect I'm seeing, is it because this tab is connected right into the control, or is it because this tap, or is it because of this tap through this resistor? So if it's through the resistor, then the lowest I should get here, oh, I don't know what it would be. It wouldn't necessarily be the, wouldn't it work where the wiper goes past this point and you can see it because the resistance goes up and down instead of just one way? Down, 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 and then back up. Up so high it's beyond the range of the meter. 2. So what's happening is I'm inside the contact is moving past this tap. As it reaches the tap, the resistance falls to almost 0 or 0 right there. And as you continue by, you start increasing your resistance again. That's perfectly normal. Now, the question is what happens with this one down here? What's going on with this? We should get the same effect, just in a different place. So we should go down, 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 then back up, and it does. So okay, so it's an actual. So this control is not matching the schematic. So what? So I didn't use the schematic to figure out how to do this. I just replaced the capacitor as it was. I didn't even touch this resistor. Wrong size capacitor. This is different. This radio is different than the schematic. The size of the capacitor is different. Nip that capacitor right out of there and see what happens with the radio. If its volume returns and everything starts working again. The purpose, I believe, is to cause a treble cut at low volume. That doesn't quite make sense. You want to try to boost up the bass. In fact, you want to try to boost, on your graph here, you want to try to boost the bass and the treble when the volumes are low, because your ears are weak when the volumes are low on these extreme sounds. So a lot of these radios are made so that when you turn them very low, things get boosted. But that's not easy to do. That takes tricky circuitry, or even a whole bunch more circuitry, to really create a boost. So generally they're just cutting things out, and the boost would come from you advancing the volume. So how do you get more bass? You cut back the treble and advance the volume. In effect, you end up with same treble and more bass. So if I cut this free, this capacitor free, that would leave the resistor in place, but that's original. That's a 22,000 ohm resistor, short-circuiting a fair bit of the, not really short-circuiting, but in parallel with a fair bit of the volume control. Well, they could be trying to change the linearity of the volume control. Change the linearity of the volume control so it all doesn't end up at the end. So you don't have to advance the volume control and get almost nothing, then at the end, zoom, it's all there. Hey, that's kind of what this radio is doing. Kinda. I think, on the basis that I haven't got a clue what else to do, we're going to remove this capacitor while the radio is operating, or make it so we can attach it and disconnect it. I think I'll just cut it out while the radio is operating, because we want to be able to see its effect. Meanwhile, I have to put this one back on down here, because as far as I know, everything's beautiful down here. It still doesn't, what I'm doing doesn't, my theory up here doesn't really explain well why the tone control won't work. So I think I'm actually off. I think I'm actually in an illogical spot now. But because I don't know what else to do, I must follow the illogical plan here. How much time have I got left? Lots of time. My wife and I are taking a trip down to the city of Pickering today. Okay, I should solder that just to be sure, otherwise there'll be some doubt. We don't want any doubt. We have too much doubt as it is. Okay, to cut it now, or to cut it, you know what, I think I can desolder it nicely here. Let's try that. Got the soldering iron hot. There we go. Okay, perfect. Now I can do this. We can click it on and off and find out what's going on with this situation. Okay, volume down, meter away. Let's clear the deck here. Capacitor's off to start. Everything's ready, otherwise, sure, why not? Okay, dim bulbs indicate no problem. Give it the full works. Today's power from the local nuclear plant is 115 volts. Look at the volume. That's unbelievable. That was it. Tone. No, still no tone effect. Whoa! What was that? What was that? I didn't touch the other lead. Maybe this blue one I put in can't take the voltage. it's being stuck on it. Oh no, it's shorting. It was shorting against this. Oh my gosh, I'm so bad. I'm so bad. So bad. Oh, maybe that was the problem. Because this capacitor was contacting this. I think. I think that's what was going on. Most of the time when really bad things start happening with radios, I track it down to my fault. Toning? I don't think there's any toning happening. Let's put the capacitor back on now.
That car is not worth
it might pop.
Over. The homeowner tells the Toronto Sun one bandit did fire. One suspect, a 20-year-old man, was held down and arrested. The others got away.
I'm going to take take a wild guess here. And this should connect to the resistor without touching that tab. It doesn't make any sense. But we're better off this way for sure. Except still no toning. Why no toning? Okay, so I found a low volume problem, but not the tone problem. Is the tone good the way it is? Let's just...
That might be a hard stance, but I stand with Israel on that one. But now you have Trump coming in the picture and saying, I'm going to take 2 weeks to decide what I'm going to do, and we're all waiting for that.
Trump said how many people they're looking for. It's difficult to tell who would have been in the park at the time or where within the massive area they would have been.
Here's some music. Now, the speaker's out on my bench here, so the sound quality is terrible. That's not going to help much. I really have to go back in the cabinet to really know what it sounds like, but I think it's okay. The tone control cuts the treble, assuming everything is the way it's supposed to be. That's what would happen. So if you could argue then, if the tone control is not working, it just means it's full treble, which it means it's got the brightest sound, all the bass is always there. You just may not be able to hear the bass without turning the volume up to the point where you don't like the treble. So that would be the concern here. Doesn't sound that way to me. Sounds good.
Les appareils électroniques qui ont... on les
What
appelle
did you
les précédents, là. Ils ont
did
pas
you just
nécessairement
go?
d'existence, mais ils ont des...
Picked for you.
Wrong way. Oh, still got this thing. This. What is that sound? Is it coming from the antenna? It's not going to prove it. So it dropped off a lot when the antenna dropped off. I think it's a noise located in my house here. Strange. A lot of weird stuff.
Donc il faut changer l'appareil. Même actuellement avec le téléphone de ma fille, c'est un vieux téléphone que je lui ai donné, mais il est plus bon à partir du mois de juillet parce que la compagnie change de réseau au niveau des communications. Donc
Distorted at the highest
il faut nous faire
setting.
consommer des appareils comme ça parce que c'est comme ça que ça fonctionne.
Et là, pour donner un ordre de grandeur...
This is Hamilton, so it's working pretty good, I think. Again, it's all up to the antenna.
But once you get by that, it's a smooth sail up to the 427 where it does slow to keel alternating express collectors.
We're going to be on some of these highways later.
In the collectors. I closed Ramsey's for
Okay, I think I'm going to stop here for now. I've solved the low volume problem. I've done it in a clunky way, but it's the low volume problem is solved. Tone thing, I still don't understand what's going on there, but it seems to be unimportant at this point. Since the volume is returned, I think the tone thing is not the biggest issue. I think an interesting thing to pursue now would be the antenna connections. What I've discovered is the shortwave connection here doesn't seem to feed any signal into the radio at all. So you got to kind of wonder about that. And then we also have opportunity to try a loop antenna, which I have here in my shop. I'll show it to you so you know what I'm talking about. I'm talking about one of these guys here. Try this on the radio as a loop and see how well it works. And that's soft type, maybe, yeah. So the bottom line is, next time we're going to focus on the antenna and its connections. Great. Okay, well, thanks a lot for watching. And we'll see you in the next one. Bye.